I'd like to spend a few words on EVOX as a platform. Now, why a platform? Because what you will see today is basically a first step of a journey of rejuvenation of our light-duty product range. You know, we have a very wide product range that goes from very few Newton meters up to 2 million Newton meters in terms of different technologies, different gearboxes. When we look at the light duty, we're basically talking about few Newton meters up to around 10,000 Newton meters. This is a journey because this is the first step, and why a platform? Because all the products that will follow up after this, they will have to respond to the same value creation drivers that we have identified for this platform, which are the ones that you're seeing here in this slide. So simplicity, efficiency, versatility and flexibility, performance, and IoT readiness. Now again, within this platform, there are three kinematics basically. Today, there is the helical level, there is the helical parallel offset, and then what we're going to talk about today is the helical coaxial. Now, we will use basically these 5 pillars as the agenda of the presentation of today. We start from simplicity. Like, you know, it's easier to make a complex product than it is to make a simple one. From the beginning, our design effort, and also during the the process of generation of ideas, we started from the concept of we want a simple product. In every possible form, you can deploy this concept. How easy it is to manipulate it, how easy it is to handle it, how easy it is to wash it. Even the way it looks should convey this message of simplicity, and also, of course, always how easy it is for the customer to use it. Now, as a matter of fact, when we talk about this product segment here, there is a de facto market standard out there which we don't fit into with our current offering. With this product, we're going to make it easier for the customer to consider us as an option. Efficiency. Well, I'm sure that I'm not the only one in this room being very aware of the increasing and over-increasing attention that there is on the on this subject here of energy saving, energy consumption, efficiency, reduction of operating of manufacturing costs. The International Energy Agency suggests that 40% of the global electricity consumption is basically generated by electric motor-driven system. Now, we manufacture gearmotors, so for us it's very important to pay much attention to this trend. And as a matter of fact, the countries, the governments are putting in place so-called minimum efficiency performance requirements, standards, that are basically set the rules, set the route. If you want to use a motor or sell a motor inside this region, you have to comply with certain efficiency. Of course, the gear motor, the EVOX gear motor, and the platform itself will respond to this bar, to the most severe requirement, minimum requirement in terms of efficiency, which are the ones that you see on the map right now, on the slide right now. So it's IEC IE3 in Europe, it's the equivalent NEMA premium in North America, and there is the ABNT IR3 in Brazil. Now you see the gray areas. The gray areas, of course, doesn't mean that they don't have minimum requirements. It just means that they are lower than this. But every other month, also yesterday we received some feedback from news from China. Every other month there is a country that is following suit. Now you see there are 2 dimensions on to take into consideration when we talk about minimum requirements. One is the efficiency, but the other is the extension, the range of the product that are, let's say, influenced by these minimum requirements. Now, IE3 is one of the dimensions. The other is how extensive it is in terms of coverage of power in the case of the motor. Now, if you look at Europe and North America, the requirement, the minimum requirements start at 0.75 kilowatts. Strangely as it sounds, Brazil is right now is the toughest country in the world in terms of severity. But as you can see, we will offer the let's say the IE3 compliance right from 0.12 kilowatt, because anyway we're anticipating decisions that will be taken and follow suit. Versatility and flexibility. Our EVOX coaxial gear motor comes with a very vast array of variance configurations. You can see there, it's, of course, we cater both the metric and imperial system output and input shaft. It comes in the feet setup. It comes shaft mounted together with the output flange. It comes together, feet and flange. Very wide and large array of available ratios, 2 stages and 3 stages. And of course, it's ready for all the possible input connections, starting from our own design compact motor, which is the most cost-effective and let's say space-effective, dimension-effective solution. But of course, we are predisposing the gear motor, the gearbox in this case, to accept standard IEC and NEMA motor, again, Bonfiglioli or third parties, and or if the customer doesn't need a motor, there is the input solid shaft, and again, both in metric and inches and imperial solution. Now, during the design of the gearbox, we had to balance basically 3 forces that do not always go hand in hand. On one side, we want a very large, let's say, range of configurations available, standard configurations available for the customer. Of course, we wanted to give it to the market with a top-class lead time, yet we have to keep an eye on the working capital. So you could satisfy the 2 points that I mentioned before with a very big stock of components, but of course this would not be the most effective way from the organizational standpoint. So the solutions that we adopted throughout the development of this gear motor product range were aimed at harmonizing these 3 different needs and forces. Now, the first one, we're moving, compared to today, we're moving from a sub-assembly logic assembly principle to a component-based logic. The reason is straightforward. Like if you think about the stock that you need in order to assembly 2 gearboxes from sub-assembly, and let's put it, it's X amount of money you have to keep there. With the same amount of money and components, you are able to actually assembly, or the customer, of course, will be able to assembly actually an order of magnitude more number of configurations. And these immediately translate in operational efficiency on one side, and as always, service level to the customer. Keep in mind one thing, for us is very important. We operate throughout a very wide, we will supply from the plant, of course, but we operate through a wide, delocalized set network of, on one side, branches, and on the other, authorized assembly partners. Okay, so throughout all the development, we kept that in mind. We have these powerhouses dispersed around the globe that will benefit from these, let's say, from shifting from an sub-assembly to a component-based logic. Motors. With the motors, we moved in this way. We said, okay, let's keep a standard motor. Okay, the most simple, yet already enough to cater demand, a large demand of the customer, of the market. Very simple, standard motor. You can plug or unplug the feet. This is a minor issue. And then just with the use of simple shafts, extension shafts, then you can start adding variants and options there. Of course, the brakes, the hand release lever, the servo fan, all those combined. And again, with an additional shaft, also encoder canopy, brain canopy, and so on and so forth. Again, this goes exactly in the direction that I said before. You can keep an X amount of standard motor in-house, and then just add on let's say the variations that you need on the basis of the customer needs. Another couple of characteristics which may sound simple but have very pragmatic and significant impact again on the flexibility and on the working capital of our partners and of our customers as well. The terminal box. Now today, the customer, when has to configure a gearbox, so has to order a gearbox, he already has to know where it will be installed. And because the terminal box, once it gets out of the factory, it stays there. Now with this new solution, we basically, the customer itself can orientate, is free to orientate the terminal box in the position that he prefers. And again, this is very simple. Let's say that a customer has different machines and he has a stock of components for those machines, and these different machines have different available spaces for the gear motor. It's going to be, before it needed at least 3 product codes and 3 gearboxes. Today you can have 1, and of course proportionate to the volumes, but let's say today you can have 1 and then use it depending upon the need of the moment. On the other side, there is the 9-pin connection and the let's say the theme of the voltages and the frequencies and the windings of the motor. The EVOX gear motor comes in 7 windings, but with 1 winding, and thanks to this 9-pin connection, usually it's a 6-pin. 9-pin because it gives us the possibility to, with 9-pin and 1 winding, basically to set up voltages and frequencies to satisfy India, Europe, USA, and Australia market. Again, same as before. Think about stock of a distributor rather than an OEM that is exporting its machine. With less part numbers, is able already to just adjust just with the 9-pin connection to cater the requirement of these different countries. Of course, with the other 6 windings, we will be able to satisfy the requirements for the other countries not belonging to India, EU, USA, and Australia. Last but definitely not least, this gearbox doesn't need plugs, breathers, valves, because it's the gears are live lubricated. Again, this is very important because you don't need, before you needed to know where the gearbox would be installed on the machine in order to put the plug on or the breather or whatever in the right position. Today you don't need to, because the customer doesn't need to open it up. Of course, we have a plug there, but the plug is just in case the customer wants to fill the gearbox with its own oil or whatever. But the gearbox filled with oil out of the factory is for life of the gearbox. Then, of course, there's several other options. There is the explosion environments, the ATEX version, corrosive atmosphere, so C3 and C4 protection, reduced backlash. The reduced backlash is, let's say, halfway between the very high precision planetary gearboxes, which have, 2-3 arc means backlash, the standard one, which has between 17 and 20 and 25 arc means. This one is going to be between 7 and 16. So it's an halfway when you need maybe more precision than a standard application, industrial application. Of course, not yet the precision of a robotic application. Of course, we provide the brake. There is thermal protection for the motor, and then choice of encoders. If you will, the encoders goes hand in hand on the motor, goes hand in hand with the reduced backlash on the gearbox when you need more precision and more dynamics. Of course, in closed loop application. Performance. We have not accepted any compromise on the quality and the level of the components inside, also for design reasons, like we've chosen A-class components, premium brands of seals. We are manufacturing in-house grounded gears, and we use hardened and quenched shaft. Let's say this choice is an enabling factor. These choices are an enabling factor for all the benefits that I mentioned to you before. They all contribute to no oil leaks, to the possibility of not having breathers, plugs, and bulbs, very low noise, less heat generation, and so on and so forth. So the choice of components allow us to embody all the benefits that I mentioned, that I listed to you before. Then the bearings themselves are modular, and so as an option, we also offer the possibility to have higher gearboxes set up for higher both radial or axial forces, loads. As far as torque performances is concerned, we score an average 8% higher than the competition, of course, size with size. We will offer 6 sizes, as you can see there, from 55 up to 650 Newton meters, which is basically accounting for 60–70% of the market of this kinematic here, and we've chosen to go the aluminum way rather than both aluminum and cast iron for the principle that I told you before at the beginning. Simple means also lightweighted, easy to manipulate, easy to store. The last but not least, IoT readiness. This is I bet is a topic that we all have on the table somewhere. And I think that everybody is still trying to experiment and finding ways to build knowledge. Now, right from the beginning, we knew that, again, the importance of the pillars. We knew that we wanted to go down that path. We knew that we had a lot to learn. One thing that we knew already, though, was that it's very important to, whenever you have a probe inside a gearbox, a sensor, it's very important to place it in the right place, in the right spot, because otherwise, yes, you might get the data, but the data are not going to be refined enough in order to know what you need to know there. Okay, so the gearbox inside, you don't see it outside, but it's inside. Inside is predisposed to have different places where the probes or sensors can be hosted. Depending again, it's a let's say a sort of modularity, depending again on the needs of the customer, because we know some needs today, but tomorrow we might discover some new ones. The multi-sensor that we have today in the sensorized version is a sensor multi-sensor that can gauge vibration, humidity, and temperature. It has a digital microphone and also a magnetometer. It doesn't give you raw data. It actually elaborates already the data that it gathers, and it's ready to feed this data inside, for example, a PLC or an edge computer on the side of the application. Now, we have a sensorized version on one side, and the other offering is a sensorless version. The sensor, of course, one is more precise, the other is more cost-effective. The sensorless version is basically based upon a mathematical modeling of the physical behavior of the gearbox. So indirectly, because you cannot do this without modeling, okay, without a mathematical model of your physical part. So we had to model it, and then we stored it inside the inverter. And more to come by my colleague Adriano in a few minutes. We are able to mathematically derive some of the physical variables that we were mentioning before, because we know the behavior of the physical behavior of the gearbox. Again, these are the two, as always, position, more precision, less cost effective. less precision. And one thing that we've learned is that, as in all aspects of life, you don't need always top precision, and sometimes you're okay with less precision. So that's the offering right now we have on the table. And of course, we're still learning. As far as availability of the gear motor product range, we've been running lately field tests and pilot tests also with some close customers. We're going to be progressively releasing all the things that I told you about, so on the gear motor, or the gearbox and the motor, starting from very shortly from Q4, and will probably end up the release of the complete range within Q1 2021. Thank you very much for your attention. I'll be here in case you have some question afterwards. Thank you very much.